Hi everyone. We're going to start with lesson 2. We completed lesson 1 before the pandemic started. So we're going to jump right in with lesson 2, which is called Permutations with Identical Objects. So the big idea is that you'll have objects that you're counting that are the same, identical. I also will refer to it as repeated objects. So the big idea again is, like, say for example, we take the word mom, and we want to count all the arrangements of the word mom. M and M, in this case, they're identical or they're repeated. So we think of it like if I put a numbering to the M's, they have M1 and M2. Well, M1, O, M2, spelling mom, is the same as M2, O, M1. It's the same arrangement. I don't want to count it twice, so that's a repeated object. So when that happens, there is a strategy that we use to deal with repeated objects. So this is the keep in mind for that section, and the keep in mind is on page 100 in your workbook. It gives you the strategy that's used. It says for a set of n objects, if A objects are identical, another B are identical, another C are identical, and so on, then we have a formula. So let's see how this works with an example. And the example is right below the keep in mind. It's on the same page 100. Okay. So the figures to the right are to be arranged in a single row. How many different arrangements are possible? So we have 2 X's, we have 3 that look like fidget spinners, and then we have 5 stars. So if I think about the idea that I'm gonna line them up in a row, and I want to count all the ways that that is possible. If I have 2 X's, well, if the X's are like this, or if I switch the order of them, they're the same, they're identical. So I don't want to double count that whenever I'm figuring out the arrangements. So according to our strategy, what we do is we take the total objects, the total number of objects, which in this case we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 objects in total. And so that's going to go 10 factorial. We'll have a fraction that goes on the top of the fraction. And then what we do is I'll say we'll divide out the repetition. So it becomes a fraction, so we are going to divide. And what we do on the bottom is we put the number of repeated objects, like how many times that it has happened, factorial. So for example, there are 2 X's, so I would divide out the 2 X's factorial, right? Those being the X's. I have 3 what I'll call fidget spinners, so since they're all the same, there are 3 of them, I'm going to divide out 3 factorial. And then I have 5 stars, so I have 5 factorial that I'm going to divide out. And you just put that in your calculator, and you'll get the answer. The one word of warning, whenever you're putting it in your calculator, is if you have a fraction template, use it. If you don't, for the older 83, 84 models, you must bracket off your denominator. Otherwise, the calculator is going to do 10 factorial divided by 2 factorial, then it's going to multiply by the 3 and the 5 factorial. Okay, so you want it grouped, so put those brackets, use your calculator brackets, and you can put it in just like that, 10 factorial divided by bracket, and you'll get the right answer. Okay, so at this point now, you want to pause the video, and you're going to complete the problems on page 101, and this is in your student outline, page 101, numbers 1, 2, and 3. When you think you've got it and you've checked your answer and everything's good to go, start the video again. I'll explain the answers to 1, 2, and 3, and then we'll do one more example together with repeated objects. Okay, so hopefully you feel pretty good about these questions and the best basic idea of repeated objects. I'm going to go through them really quickly just to make sure that you get it. If you understand it and you don't need this explanation, you can just fast forward. The one thing for number one, though, I want to talk about, though, is how to not use a calculator whenever doing some of these problems. 1A is just all putting it into your calculator, but I want to show you the expansion of the factorial because there are some problems in the review and just for your own benefit. So if I take D, because it's right here closer to me, 10 factorial over 5 factorial, 3 factorial. If I'm going to use the calculator, I'm going to bracket that bottom off. But I can also think about what I call expanding the factorial, which is going to speak to what is a factorial. So 10 factorial would be expanded out showing all the factors. And then the 5 factorial and the 3 factorial would factor out to look like that, showing their factors. If I then think of it like a fraction and canceling things, I change colors to show what cancels. 5 divided by 5, they cancel. We call it canceling in the math world. It really divides to 1. So the 4 over the 4, the 3 over the 3, the 2 over the 2, and of course the 1s don't do anything anyway. And then I have this 3 times 2 times 1. So all of this 5 factorial canceled with that last part of the 10 factorial. But these will also factor because 3 times 2 are they're canceled. 3 times 2 is 6, so that can cancel with the 6. So really, I'm just left with that. Makes it a little bit easier to put in your calculators. It creates some thinking depending on where you're going next. If you're going to continue on doing some math, it's just a good thing to have. So you can do that with number 1. Number 2, it's similar to the example we did. So this time we want to think about the total number of objects. 1, 2, 3, 4, 5, 6, 7, 8. There are 9 objects. And so I would put 9 factorial, and then I would start to divide out the repetition. Now this next one's a little bit different in that how many arrangements are possible if the middle figure must be a star. So then I can think about, well, if the middle one has to be a star, then I can just take it out of the mix altogether. So now I just have 8 objects, 3 of them will repeat and 4 of them will repeat. And then how many arrangements are possible if the middle figure is not a star? Then I can think about my answers to both part A and B. So if this is all the arrangements, which I believe is 1, 2, 6, 0, so if that's all of the arrangements, I'm going to take out the number that have that star in the middle, which would be, that was 280. So then this would be star in the middle. So you can think of it like a subtraction problem. Instead of trying to count all the ones where you don't have a star, we'll just take what we have already, the total minus if it is in the middle. And then number 3 is a very popular question because words, it's a great way to test this idea of repeated objects. So if I have the word rearrange, I can already see that I have repeated objects. So I would count the number of letters, 1, 2, 3, 4, 5, 6, 7, 8, 9 letters in total, that's the top. And then I just want to divide out all those repetitions. So I have 2 A's, I have 1, 2, 3 R's, and I think that's it for my total. Nope, I have 2 E's. And I could put that in my calculator. Okay, so I'm going to end this video just so they don't get too long, and then we'll do example 2 together.